All right, this is a very important topic, and that is LC oscillation. So, we know that a capacitor and an inductor they are used to store electrical energy and magnetic energy. Okay, so when the two are connected, you will find that both charge and current oscillate back and forth between the two components. So, this type of oscillation is known as LC oscillation, where L here stands for the inductance of the inductor and C is the capacitance of the capacitor. Alright, so let us look at this figure 1. In this figure 1, I have this is a capacitor, and this capacitor it is fully charged up to a charge Q naught. Okay, so this plate is positive and this one is negative. Now this is a key which connect the capacitor and the inductor. So when the key is open, right, there is no charge flowing through the inductor. But as soon as you complete the circuit, you complete the circuit, then what will happen? This capacitor here will start discharging. Okay. Okay, before that, because here this capacitor contains maximum charge, so then I can see here that the electrical energy which is stored in the capacitor is maximum. And for that we write UE equal half Q naught square upon C. Whereas since there is no current or no charge which is passing through the inductor, so the magnetic energy which is stored in the inductor at this time it is equals to 0. Okay. Now in this figure 2, I have connected the capacitor with the inductor. So when you connect the two, what will happen? The charge from the capacitor will flow through the inductor, which means the capacitor, right, begins to discharge. Or I can say the charge in the capacitor starts decreasing. Okay. So because of the flowing of charge from the capacitor to the inductor, it means a current is passing, right? A current is going through the inductor. If this is the positive plate, then the current will start, right? From this positive plate, it moves to the inductor and come to the negative plate. Okay. So this moving of charge or the transfer of charge from capacitor to the inductor, for how long it will take place? So this transfer of charge is taking place until all the charge in the capacitor is completely zero. Okay. So when this capacitor start discharging, then you will find that the electrical energy which is stored in the capacitor starts decreasing, whereas the magnetic energy in the inductor will start increasing. And when the capacitor is completely discharged, then what happened? The charge at the time will be zero, and because of zero charge in the capacitor, the electrical energy in the capacitor will be equals to zero. But this energy in the capacitor, it is fully transferred to the inductor. Or I can say the magnetic energy in the inductor will become maximum at the time when the charge in the capacitor is equals to 0. Okay, so this is UB, and UB here stands for the magnetic energy, and this is maximum. For maximum energy, we write half L I naught square. Okay, where I naught here is the maximum electric current. Okay, now because of the increasing current which is flowing through the inductor, then the magnetic flux which is linking with the inductor will start increasing. So that increasing flux will in turn produce the induced EMF in the inductor. And the polarity of the EMF which is induced in the inductor, it will be this side will be plus and this will be minus. Why it is so? Because if you remember from Lenz's law, it says that the induced EMF or the induced current will be produced in the circuit in such a way so as to oppose the cause that produces it. So previously the current, right, it is coming, right, this side is positive, current is going in this way. Okay, so if current is going in this way, then, sorry, I made a mistake, this should be plus, this should be minus. Okay, so the EMF starts building up in this way so that this side will be positive and this will be negative. And when this is positive, then the current now, right, that means this inductor, it will start charging the capacitor again, but in the reverse direction, which means this end is positive, then from here, right, the current will start flowing back to the capacitor. So when the current is going back to the capacitor, it means you are charging the capacitor. So this EMF here will start charging the capacitor. As it charges the capacitor, what will happen? The magnetic energy that is stored in the inductor will start decreasing, whereas the electric energy which is stored in the capacitor will start increasing. And when the magnetic energy, right, it is totally, I mean when this inductor is totally transferred its energy to the capacitor, then you will find UB is equals to 0 and the electrical energy UE again become maximum. Okay, but the nature of charging the capacitor is different, right? If you look at this figure 1, this side here is positive, but when you recharge the capacitor, you will get this side is negative. Again, you charge the capacitor up to the same maximum value Q0. Okay, but in the reverse direction. Alright. So again, after this capacitor here, it is fully charged. Then this capacitor again will begin to discharge. Right? As it discharges, it means now this side is plus. So the current will be moving from this plus to the inductor in this way, as shown here in this figure 4. This is figure 3. This is figure 4. Alright. So the charge will be moving in this way, which means the current is going in this direction. Right? So because of the discharging process of the capacitor, you will find that the electrical energy in the capacitor again will start decreasing, whereas the magnetic energy in the inductor will start increasing. So when the capacitor is fully discharged, then the electrical energy will be 0, whereas the magnetic energy in this case will become maximum. Again, it will get back half L I naught square. Okay. Now, because of the induced EMF in this case, then you will find the polarity of the inductor will be like this. This now will be here like plus and this will be like minus. Why it is so? Again from Lenz's law. So because of this, then what will happen when the capacitor is fully discharged? The electrical energy is 0 and the magnetic energy here become maximum. So after this inductor gain maximum energy, then it will recharge the capacitor but in the reverse direction. That means it will try to give, the charge to the capacitor. Like in this case, it is giving the charge in such a way that this side is minus, this is plus. But now it will give a charge to the capacitor so that this will be plus and this is minus. So this process continue until the capacitor gain back that original energy, which means the electrical energy will become half Q0 square upon C, and then this capacitor, as it fully transferred its energy to the, as this inductor is fully transferred its energy to the capacitor, then you will find the magnetic energy in this case is 0. Okay, so this is my figure 5. So this figure 5, it is same as figure 1. Like you are going back to the original position, isn't it? So in this way, the process keeps on continuing. Okay, which means in this case, the charge from capacitor and inductor, it is oscillating back and forth. All right. Not only the charge, even the energy also, it is fluctuating, or I can say it is oscillating back and forth between the capacitor and the inductor. So this process of oscillating of charge or electric energy or energy, simply energy, between the inductor and the capacitor is known as LC oscillation. Okay, so in the next video we shall see about the we will discuss about the mathematical treatment of this LC oscillation, and you will see that the graph of the charge and the electric current which is passing in this case, right, it is a sinusoidal graph. So for that we will see in the next video.